Energy is all around us, from our taps running, which demonstrates the transfer of gravitational potential energy into kinetic energy, to us walking, which transfers chemical energy into kinetic energy, whilst dissipating sound and thermal energy into the surroundings as waste energy. Or, when you turn your phone on, this is an example of chemical energy being transferred into light energy, whilst dissipating thermal energy into my hand. But what actually is energy? Energy is the capacity for work to be done. Interestingly, the energy around us has been here since the dawn of time. But why? This is because of the law of conservation of energy, which states that energy cannot be created or destroyed, only transferred between energy stores. Let's see how this law is wielded into our theory.
Our primary goal is affordable and clean energy. However, the way in which we aim to achieve this goal also serves as effective in tackling climate change and promoting good health and well-being. Most of the people in the world, in fact most of us, participate in physical activity every day, whether that be running late to school, walking to work, or taking part in a sport. Briefly, what we propose is a mechanism in which we turn what scientists call as waste energy into useful energy. In other words, energy that we can use as a part alternative to electrical energy. It is key to note that this is only a part alternative, as the conserved energy can only operate to a limited extent. However, it still eases the demands on fossil fuel electricity, therefore reducing air pollution as well as promoting healthy living and an active lifestyle. When you would be walking, you would lift your foot up and place it back down. As you do this, the elastic bands will move the static magnet up and down. The movement of the static magnet causes an induced potential difference across the ends of the wire as the coil is crossing the magnetic field lines. This is the process of electromagnetic induction. Since the coil is part of a complete circuit, the induced potential difference makes an AC current pass around the circuit. This is a generator effect. The induced current creates its own magnetic field, which opposes the movement of the magnet. Because the induced current makes it harder to move the magnet, it means that the work is being done. We are transferring energy from the movement of the magnet into the movement of the current. This is the gravitational potential energy in the foot being conserved and transferred as work done. The current passes through the bridge rectifier, which turns the AC current into a DC current, to be stored in a battery power bank as chemical energy.
We're now going to be looking at the mathematical logistics behind this ideal. For us to be able to do this, we will need to calculate the gravitational potential energy using the following formula. EP equals mgh. Now, the mass of an average human being is approximately 70 kg. The gravitational field strength on Earth is 9.8 newtons. Now, when you're walking, the change in height is approximately 5 centimeters, and as we need this value in meters, that will equate to 0.05 meters. Now, if we substitute these values into the formula, we will get 70 kg multiplied by 9.8 newtons multiplied by 0.05 meters. Altogether, that will give us 34.3 joules of energy that has the potential to be transferred into chemical energy to be stored in a battery. If we round this value to the nearest 10, we get 30 joules of energy. In other words, assuming 100% efficiency, an average human being can transfer 30 joules of energy from the gravitational potential energy store of the foot to the work being done to transfer energy from the movement of the magnet to the movement of the current. Assuming 100% efficiency, if a person walks 5,000 steps, then 150,000 joules of energy can be transferred from the gravitational potential energy store to work done. Now, an iPhone battery holds 18,000 joules of energy. Therefore, 150,000 joules divided by 18,000 joules means that you can charge your iPhone, assuming 100% efficiency, 8 times. However, as we know that nothing can be 100% efficient, assuming 50% efficiency, you would still be able to charge your iPhone 4 times. It's important to remember that there are variance in the values provided above. For example, a person could walk more or less than 5,000 steps. A person could weigh more or less than 70 kg. In addition, a person could lift their foot up more or less than 5 centimeters. However, in all cases, enough energy can be generated to charge electrical appliances to a sufficient amount. In regards to increasing the current and therefore improving the efficiency, there are a number of ways this can be done. 1. Using a stronger magnet. 2. Moving the magnet more rapidly. This can be done if you're taking part in a physical activity or you're running. 3. A tighter coil could be used. As such, the greater the number of turns of the coil, the greater the end-use potential difference and the current. All the before mentioned helped in increasing the current, which therefore improves the efficiency by which the 30 joules of gravitational potential energy can be transferred to work done, on which energy is transferred from the movement of the magnet to the movement of the current. To conclude, we walk almost every day and energy is wasted as it simply dissipates into other forms of energy which aren't accessible to humans. But the point is, it can be, and so it should. When researching solenoids, we came across bike dynamos which we found to be similar to solenoid technology, and they were 80% efficient. Our idea, simply put, generates electricity by walking, therefore providing a clean, accessible and sustainable source of energy. What's more, our idea provides people with an incentive to walk, therefore promoting healthy living. All in all, energy is always transferred from one source of energy to another. Therefore, we raise this question to you. Why not transfer it to a usable energy store?